I'm Amandeep, and I'm talking about the average performance, an almost completely useless metric. So a lot of the time recently, when I hear people talking about some system they'd like to see developed or some system that they're trying to learn about, one of the things that people ask is, what's the average performance of this? And that's kind of a pet peeve. The reason is because a lot of the time when people are asking for the average performance of something, I think what they're actually looking for is what is the typical behavior of the system. And in reality, the average is not going to tell you what the typical behavior is, unless you live in a very special world, and that's this, this like Gaussian or normal distribution world, or something, where at the very least you're kind of evenly weighted on the right and left sides of a mean. So just to make a really quick example to demonstrate this fact, I decided to create a simple little data set where I pinged Google a bunch of times, and I looked at how much time each of those pings took, and I put them into this histogram. So on the x-axis here, we've got the length of time a ping took, and then on the y-axis, the number of pings that took that much time. And I have like a little over 150 samples. So if we kind of eyeball this, we can see that more than 100, most of these pings took about 26.5 seconds, right? So you might think, okay, that's kind of typical for this. But if you actually put the average or the mean on there, that little red dashy line, that's at 29 seconds. That's higher by about 10%. And we can see that it's not really capturing the main performance here. Just a very simple example. And if I happen to plot the 75th percentile on this, it turns out that lies almost where the mean does. So what that means is, if I told you the average of this, I'd actually be telling you a time that was slower than 75% of the time, right? So if you're really attached to just like, I want a single number, just tell me one number that encapsulates what's going on here, the median is usually a slightly better choice. By definition, 50% of things happen faster than the median, and 50% of things happen slower. But, that works okay in this case, where you've got like nice data, it's all smooth, it doesn't really have any gaps in it. But a lot of the time, that's not really the situation that you're dealing with. A lot of the time, you're dealing with what's called modal data, right? Where you're just getting like one thing over and over one thing until you cross some threshold, and then suddenly you're getting something completely different, right? And there, it doesn't really make sense to report an average, because I'd be reporting something to you that you never actually see, right? So just to give you a little bit more of a relevant example, I snatched this plot off of Steve Newman's blog, his post entitled, "You Can Learn a Lot from a Histogram." And he's just got some data here where he's reading 4 kilobytes of data out of a random position in an 8 gigabyte file off of Amazon's Elastic Block Store. So we can see that most of the time that file read happens in 13 milliseconds, right? I would call that like the primary mode of this modal distribution. But we can see that there's like 3 other modes there, right? And sometimes you can read this data, in 10 microseconds. So if we thought about this for a second, we could maybe realize, okay, maybe this has to do with different levels of caching, and these different modes have to do with the fact that I'm a lot more likely to get a cache miss than a cache hit. But when I get a cache hit, it's fast, right? If I were to try to just give you a single number to encapsulate what was going on in this complex system, first of all, I'd give you a number that probably doesn't appear anywhere, doesn't represent anything, and it really wouldn't tell you what you need to know. I'd be telling you to expect like a herd of unicorns, when really you should be expecting mostly zebras, right? And you could be missing out on an opportunity by examining what all those different behaviors were to make your system better, right? Like maybe, if you were trying to do what he was doing, you could try to optimize your system so that most of the time you're getting that 10 microsecond cache hit and getting the data a lot faster, right? So the main point of what I'm trying to say here is that first, the average, most of the time it's really not what you're looking for. But in general, we should just ditch the idea of trying to like talk about what a system's doing in a single number. in general, it's a lot better to kind of give like benchmarks and say 50% of the time, I want to see this. 75% of the time, I want to see this. 99% of the times, I do not want to see anything that happens like this, right? That's a lot more informative. And it's important if you're collecting information on how a system's performing that you note and understand all the features in your data. Don't just throw it away or lump it all into one number. And for those of you that are interested in maybe how we measure things and actually do a good job, and a talk that really goes into a lot of detail, I'd recommend Gill Teens' How Not to Measure Latency, which is an hour long. But yeah, that's the end of my rant. Thank you.